Welcome. This question says a solid cylinder has a radius of 4 meters and a mass of 2 kilograms. What is its moment of inertia about an axis through its circular center? So let's visualize to begin with. So here we have our solid cylinder and we have a certain thickness to it. And the axis we're considering is this axis there. It's basically, imagine the cylinder is rotating clockwise or counterclockwise about this axis. And quite simply, just want to know what the moment of inertia is about this object, about this axis. It's got a radius of big R, it's got a mass of m, and the first thing I need is an expression, and I say I is equal to, and I can say, if I wish, I can say it's going to be r squared dm, but as we found out previously, that simplifies to, or that derives it into 1/2 times m r squared, where m is the mass of the cylinder and r is the radius of the cylinder. So I, in this case, would equal 1/2 times m, and for this case m is 2 kilograms, so that would be 2 times r squared, and r squared, well, r is 4, so that would be 4 squared. So I would equal 16, and it would be kilograms meters squared. And it really is as simple as that. There are 3 shapes that you should be able to write an expression for the moment of inertia about their symmetrical axis, and that would be the solid cylinder. I solid cylinder is equal to 1/2 m r squared, and I hollow hoop is equal to 1 m r squared, and then we have the sphere, solid sphere. Yeah, sorry, I just realized that should be solid cylinder. I was thinking, man, they both use the same symbols, but they don't. So for the solid sphere is equal to 2/5 m r squared. So you should know these, commit them to memory, and then recognize that this is the number 1. This has the biggest moment of inertia about its axis of symmetry. Then next we would have, this guy would be number 2, and then this guy is number 3. This guy has the lowest moment of inertia. So for example, if we had a race between a solid cylinder, a hollow hoop, and a sphere. So this is a solid cylinder, hollow hoop, and solid sphere. If we had a race between these 3 shapes, they've all got the same mass, they've all got the same radius. The one that would be most reluctant to accelerate would be the hollow hoop. That would be the one where its mass is on average further away from this axis of rotation than it is in the other 2 objects, and so that would tend to accelerate to the least extent, and so it would increase its velocity slowest, and so this would come in last. So this would be last. And the one that has the least moment of inertia, which is the solid sphere. The solid sphere would come in first. It's most comfortable accelerating, and so it's the first to increase its speed, and so it will tend to have bigger velocities at any given point or any given time, and so it will win the race. And the solid cylinder is in between the two of them. Not quite as low a moment of inertia as the solid sphere, but certainly not as big a moment of inertia as the hollow hoop. So this would come in middle. So good conceptual visualization. Know these equations, just be able to use them in an expression when the question is not particularly about this knowledge, it's just using this knowledge. There we have it.